let's start coding away. For now, don't worry if you don't understand what's going on. You can just follow along. I'm going to start by right-clicking on the project name here. Go to Properties. Go to General. But before that, I guess you couldn't really see that. So let me bring it here. Right-click, Properties. Go to General. I'm going to make sure that I'm using C++ 17. And you can put this Solution Explorer anywhere you want to. I'm just going to put it here. And I'm going to start out by saying that we have our video game, and inside our video game we have the player. The player has HP. So I'm going to say int HP equals 5. I'm going to run this code by clicking here. Okay, we have nothing in our app. I'm going to say stdcout player HP is, input the variable HP, and then end the line. Okay, again, I'm going to click here. And here's our game. Let me add a little space here. Okay, player HP is 5. And all this green stuff, they're not part of your code. They're comments. And you can write comments by using the /. It's just there for human readability. It's not for it's not part of your code. This is for human readability. Okay, if I run this again. Okay, here's our result. This is now part of the result. And in case you have some wrong Visual Studio settings where the window closes automatically, you see it here, but sometimes it shows for a single frame and just disappears. As a quick solution, you can do this. I'm going to say a string cin. This means that we're going to wait for the user input, and after we get the user input, we go to the next line, and then that's the end of our program. So if I run this again, okay, after we say player HP is 5, we're waiting for the user input, type in whatever. If I press enter, that's when the game ends. Okay, so use this if you have the auto close. You could use Visual Studio settings to mitigate this. There's a lot of settings under tools, options, but if you're starting out, this is just confusing. As a quick solution, you can use this. And just out of habit, you might see me pressing Control S a lot, or you might hear me pressing Control S a lot. So if I change this to something like 10, you see the little mark here, the change. I'm going to press Control S. It's saved, but even without manually saving, if you just run this, Visual Studio does it for you. Okay, player HP is 15. Let me try 8, run the debugger. Okay, and let's get on with our game. I'm going to say HP -. This means that we're going to bring down the HP by 1. So after I bring down the HP, I'm going to say your HP is now HP, the variable. Again, if I run this, okay, in the beginning our HP was 8. After HP -, HP is 7. And you can also press F5. Okay, I've now changed it to 10. And after -, it's 9. I can also do HP++. And you can guess that it's the opposite. I'm going to say your HP is up. F5. Okay, 10, -, and ++. Easy stuff. There are many things that you can express on your computer. So far, we've only expressed integers, which is HP. But I can also say bool, which means true or false. As a variable name, I'm going to say player is dead. I'm going to say true. So down here, I'm going to ask, or I'm going to type in is player dead, and that's the answer. I'm going to put in the variable player is dead. In our case, the variable is true. I'm going to press F5. Okay, is player dead? And it's true, it's 1. And if I change this to false, you can probably guess that you're going to get 0 instead of 1. So 1 is true, 0 is false. There's many variables that you can type in. We can also do decimal points. For example, I can say float. And let's say the player is on some sort of a grid. And let's say the grid position X is something like 1.5. So I'm going to say X position equals 1.5. This F here refers to the single floating point value. For now, don't worry too much about it. It just means there is a certain way to express your decimal points. So down here, I can say player position X, and I'm going to use the variable X position. If I press F5, okay, here's our result. And I think that's enough code for day one. I'm going to dig a little deeper from here. And you don't necessarily have to understand what I'm going to say from this point, but just understand that these fundamental concepts will help you understand read and write code better. So I've written a little app to express something called binaries. I have all the links below so you can download this. But what do binaries mean? It means somewhere on your PC or your Mac or whatever, you have a bunch of ones and zeros. Now, in this example, I've expressed it in light bulbs. So we have 32 ones and zeros or 32 light bulbs. Using these light bulbs, you can express an integer. So here's 1, that's 2, that's 3. And every combination represents a different integer. And with 32 light bulbs, you can guess that there is quite a lot of combinations that you can express. I'm sure you've heard of the terms like megabytes, kilobytes, gigabytes. Well, a single light bulb is a bit. A single byte has 8 bits in it. And an entire integer, a single integer, has 32 light bulbs, or 32 bits. And you can guess that when I say a single gigabyte on your RAM, you can guess that there is a shit ton of different combinations that you can come up with on your RAM. You might think that ones and zeros are cheap, but that's just hardware being developed over decades. The more ones and zeros you acquire, the more expensive your machine is going to be. For now, don't worry if you don't understand how to turn binaries into integers. Let's just understand that a certain combination will give you a certain integer. And if I turn everything on, maybe I should have a button for this. So I'm going to turn everything on except 1. We get 2,147,483,647. And if I go the other way, turn this on, turn everything off. Okay, we get negative 2,147,483,648. This last light here represents positive or negative, and you can get any integer between this and the maximum number that I just got. You can also do this on your calculator. I'm going to get my calculator app for Windows. And usually these things come with a programmer option. So I'm going to select programmer. I'm going to select binary, and we can only press 1 or 0. So if I do something like 1110, just some random numbers. And if you convert that to decimals, it's 230. I can add more ones and zeros. Okay, here's the binary, and this is a number that we're all used to, 236,430. Okay, in binary, that's 111001, you know, whatever. But what about decimal points? Let me get my MS Paint and pretend that you're writing on a piece of paper. To express decimal points, you can just go 1 dot or 1.11111. You can just keep on adding more numbers. But like I just said, ones and zeros are limited on your computer. You can't just slap on more numbers when you're coding. So people decided that floats are going to use the same amount of ones and zeros as integers. We just have a different way of interpreting those ones and zeros. For example, I can do hold on. Okay, so if you interpret these ones and zeros as floats, it's close to 3.14. If you interpret these as integers, it's this number. You have to be careful with floats though. Let me explain. In math, you have something called real numbers, as in any point you can pick on a line. For example, you have 0, you have 100, you have negative 100, and real numbers can keep going, of course. And you can pick any point on the line. For example, if you pick really close to 100, you're going to get something like 99.999999999. Or you can pick something really close to 0. You can pick 0.000001. A 0 or 100, negative 100 would be integers. A 0.000001 is a real number. Now, remember that I said ones and zeros are limited on your computer. You can't possibly have every real number on your app because at some point you're going to run out of ones and zeros. So for floats, we use the same concept that is used in the scientific notation. For example, when you express the speed of light in the scientific notation, we say it's 3 multiplied by 10 to the power of 8. This is the same as writing 3 and 8 tens, 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. But with the scientific notation, you can tell that we're using significantly less amount of numbers, even though we're expressing the same value. With limited amount of ones and zeros, we use this equation to express fractional values. This is not going to give you the actual real number that you want, but instead it's going to give you something that is very close to the real number. So this first light represents S, positive or negative. The next 8 represents M, or the mantissa, and the rest represents the exponent, E. It does require more steps in the scientific notation because here we're counting in 2s instead of 10s. And I've created my own Excel file for this. As you can see, we have a bunch of ones and zeros that represent either S or E or M. It's from the equation that I just showed you. And right now you can see that we have the result 3.14. But depending on what number, or depending on the combination of the binaries that I have, I can change the numbers, either 1 or 0. And we see that we get a different float value depending on your combination. Now, I have all the links below so you can download this, but you don't have to do this yourself. You can, if you just Google something like converting binary to float, you're going to see the entire process, a whole bunch of articles, as well as a whole bunch of different videos. The next question is, how much are we approximating? We want to know how precise our float values are because we want our game to be as precise as possible, but at the same time, we don't want to be using too much resources. So if we look at the light speed example again, the actual speed of light is something that is closer to 2.998 multiplied by 10 to the power of 8. Obviously, 3 uses less digits or less resources, but it's also less accurate. This part of the equation, or M, the mantissa, is the part that determines your accuracy. The 2.998 uses more resources, more digits, but it's also more accurate. So you can think of it as a trade-off. For example, when you say something like float f 4.9999999, when you do something like this, Visual Studio is not going to give you the actual real number. If I hover my mouse over it, you're going to get something that is very close to 4.9999999. In a similar sense, if I say 3.14, Visual Studio is not going to actually give you 3.14. It's going to give you something very close to a 3.14. I recommend watching this video on how the numbers are actually converted, and you should try this yourself on a piece of paper. And you're going to see that the more digits you have, the more ones and zeros are required. You'll also see that certain fractions will just keep on going if you try to express it in binary form. The amount of ones and zeros that you have in a float limits you to only the accuracy of 6 digits. You shouldn't go beyond that because starting from 7, you're going to start to have bigger and bigger approximations, meaning you're going to start losing your accuracy. What do I mean by that? Well, in most games, you're going to see float values like 0 point something, 1 point something, 10 point something, maybe 100 point something, because by the time you get to hundreds, once you start expressing numbers like 100.123, you're already using 6 digits, you're already pushing the limit. Hundreds might be okay because you still have 3 digits left. If you get to 1,000, you're left with just 2. So when you're designing your game, when you're using floats, be careful not to use too many digits. There are games that use extremely large numbers. Like there's idle games that go on for days, weeks, months, or even years. Those games tend to use something called big int, but we're not going to talk about that in this video. In this video, we're just going to talk about floats and integers. So coming back to the code, when you declare floats and integers like this, you're saying that you're going to use a certain amount of ones and zeros to express a certain value. It's what we call data types. Different data types require different amount of ones and zeros, as well as a different way of interpreting those ones and zeros. A bool, for example, only requires 1 byte because all we're expressing is true or false. But later you're going to see many different types of data types, and by defining how those data types interact with each other, we're going to define how our games are going to work. Don't worry too much, even if you don't understand this video. The more, as you write more code, things are probably going to make a little more sense. The takeaway here is that if you spend enough time understanding these fundamental concepts, reading and writing code is going to be a lot easier. So that's it for this video. If you have any questions, you can reach me on my Discord server. I have all the links below. Thanks for watching. See you next time.